Okay, welcome again in the product design and development class. And the topic for today is design for manufacturing. So this is the second part of product architecture. So design for manufacturing actually, if you look at the table of content is a book, it is located at the chapter 11 after the industrial design and product architecture. So in product development process, after we have done the concept development, system level design, and followed by the detailed design. So design for manufacturing actually located at the detailed design. So the question is, how can we emphasize manufacturing issues throughout the development process? It means that manufacturing issues in this case is how we make sure that the product can be manufactured. So this one example for the design for manufacturing is a machine GM 3.8 liter V6 engine. So it's very complex product, and then make sure that how we manufacture this kind of product and how to understand the manufacturing costs, because the final points, I think the objective is how to minimize costs. So manufacturing, in terms of manufacturing costs, actually consists of three things. The first one is component itself, assembly, and the overhead. So for components, we have to make sure that it is standard component, and also can be custom. But a custom component, to make sure that we have known the raw materials and how we can get the raw material from the suppliers, and the processing and the tooling system. For assembling, we have labor and the equipment and tooling. And for overhead, it is the supporting costs and indirect allocations. So it is very clear enough that manufacturing costs can be influenced by the component itself, the assembly steps, and the overhead costs. And the definitions of the design for manufacturing, or DFM, it is the development practice emphasizing manufacturing issues throughout the product development process. And a successful DFM result in lower production costs without sacrificing the product quality. Back again, guys, to the concept of QCD, quality, cost, and the delivery. And quality and cost is actually it's quite related. So we have to maintain the quality, increase the level of satisfaction of the customer. But remember, don't forget, we should maintain the quality. It means that we can decrease the cost, but we have to maintain the quality. Okay, so three methods to implement DFM. We can use organizations. We can apply the cross-functional team. I think it's cross-functional team we have already covered in the first and the second week of this class, right? In the product design and development, the cross-functional team is very important because the project management, the project manager for this product can work with other people from different backgrounds, so that the ideas will be will be rich. You can find many ideas. And then of course the design rules is specialized by firm, means that the design for manufacturing, for example, if you want to design machine, so make sure that you can find the basic manufacturing and basic machining system that applied by or specialized by a certain company, and you can do a benchmark, and then you can adopt a method that already successfully implemented by that company. And then CAD tools, or CAD, computer aided design tools. One example is from the PG software. So this is just an example. Okay, design for assembly rules, and we have a design for manufacturing, and also we have a design for assembly. So manufacturing, assembly, I think is also talking the same things. The example set of DFA, or design for assembly guidelines, from a computer manufacturer. So I think these are the general rules that not only for a computer manufacturer, but also can be applied to other manufacturer. Okay, and the first one is minimize parts count. Okay, minimize the number of parts, and then encourage modular assembly. So guys, they put emphasis on modularity instead of the integral. And then stack assemblies, eliminate adjustment, eliminate cables. So I think it is related to the subject of time and motion study, right? Use self-fastening part. So it means that we reduce the effort to do fastening, okay, to do fastening using screwdriver, for example. And then number seven is use a self-locating part that the part can locate itself. You can use Pokayoke. Is you still remember the concept of Pokayoke error proofing mechanism? And then number eight is eliminate reorientations. Yeah, it is also the same thing. It is quite related to Pokayoke as well. And number nine is facilitate parts handling and specify standard parts. Again, guys, standardizations. So key ideas of DFA and TFM: minimize part count, maximize the ease of handling parts, and maximize the ease of inserting part. So I think this point, these 3 points, quite related to what you have learned from time and motion study. Okay, you learn micro motions and you also learn macro motions. Okay, and the benefits of DFA or design for assembly is to lower down the labor cost and other indirect benefits. So again, the objective is costing and benefit. And it is the popular software developed by BND, the company. So you can take a look and you can click this link and you can find some basic concepts and the history of the company and then some example done by that company. So to compute the assembly time, we have a handling time and insertion time. So this is called assembly time. I think everybody knows, right? Assembly time. And the methods for part integrations ask of each part in candidate design. Does the part need to move relative to the rest of the device or not? If not, then I think it's better to put part not moving. Okay, no need to move. Because if your product part need to move, you have to remember that you move, then you need time. If you need time, you need more cost, right? And number two, does it need to be of a different material or not because of the fundamental physical properties? Okay, I think it is for substitutions. If the material is difficult to find, then maybe you have to think about different material. For example, now people talking about plastic. Yeah, because the plastic is not environmentally friendly. So people think about, okay, how to replace plastic, how to substitute plastic. For example, you use reuse materials or you use other material than plastic. Or maybe woods, okay, solid woods is not used anymore because of the issue of global warming. And then now people talking about they use how to say, the particle board, okay, particle board materials. Okay, number three is, does it need to be separated from the rest of the device to allow for assembly, access, and repairing or not? Okay, yes, but if it's separated, then again, guys, you need more time. But if not, then you can save time. So if not, then combine part with another in the part of device. This is the key point. So we are talking about assembly, we are talking about manufacturing. So we can apply that part can be assembly in one or maybe yeah in one combine, okay, in one combined design, or use less time, less movement, less motions, so that you can reduce the time and you can reduce the cost. Okay, I think this is the last slide. So TMM strategy is contingent. It means that it is starting from corporate strategy, move to production strategy, product strategy, and we are concentrating on product strategy, and we can apply TFM strategy. So design for manufacturing, actually, it is one activity that support corporate strategy that your company can compete with other similar companies. Okay, thank you guys. That is very short introduction of design manufacturing that you hopefully that you gain some points, and don't forget to continue your project. Stay safe and healthy. Bye. Thank you.